Pick a number, any number. I'll use 2. Now pick a different number, but this time it has to be prime. I'm using 3. We're going to make a necklace using these numbers with 3 beads and 2 different colors of beads. Let's try to figure out how many ways this necklace can look when it's unclasped, like it is now. Well, there are 2 colors each bead can be, and 3 beads, so that makes 2 to the 3 ways to make it, or 8. If we were to clasp this necklace, though, 3 different unclasped necklaces would all make rotated versions of the same necklace. For example, purple, pink, purple would be the same as pink, purple, purple, and purple, purple, pink, just starting at a different spot on the necklace. This holds true for all unclasped necklaces, except for the 2 cases where all of the beads are the same color. All this to say, the number of clasped necklaces is equal to the number of unclasped necklaces, minus the 2 cases that are all one color, divided by the 3 ways that the necklace can be rotated, and then adding back the 2 ways that are all one color. This doesn't seem all that impressive, but hang with me for a second. Let's call this number 2 that we picked A for any, because, well, it can be any number. Then let's call 3 P for prime. We can generalize our formula to be A to the power of P minus A divided by P plus A is equal to the number of ways that the necklace can be clasped. Now, here's where it gets interesting. The number of clasped necklaces is obviously a whole number, so just this part here is a whole number. That means that this section here is divisible by P, no matter what A and P are. This is called Fermat's little theorem, which he stated in 1640. Before we move on, we're going to rewrite his theorem a little bit. When you say x is divisible by y, you can express that as x is equivalent to 0, mod y. So another way of expressing his theorem is that a to the power of p minus a is equivalent to 0, mod p. Adding a to both sides, you get a to the power of p is equivalent to a mod p. And then dividing by a gets you a to the power of p minus 1 is equivalent to 1 mod p. Yay, we did it! What did we do exactly? Granted, this seems kind of pointless, but that's the reason we did it. It was completely pointless in 1640. Today, though, it's used every day, and you'll find out why in the next section.
Created using Powtoon.